Hey, Ari.
Hey, so today I'm in the car, so I'll mostly listen in and talk.
Oh, yeah. So are you actually driving?
Yeah,
So you won't be able to look at the little demo.
yeah.
We'll try to describe it a bit. Okay.
You doing a demo?
I mean, I can wait if you want, but yeah, I'm
Oh,
thinking.
no. Yeah, it's also recorded, right? So if I miss it, I'll look.
Yeah. It's just I visualize the word to vec model I've been working with. So, and I have some questions about it. So you said you're doing less NLP. What did you mean by that?
I said what?
You said you were doing less NLP these days.
Oh yeah, less NLP. So remember I was describing projects using satellite data to doing like crop masking.
Huh?
So it's for a long time I actually wanted to do those projects because they're like more classic, classical computer vision type. It's actually more like time series, even more than computer vision. But then somebody else was doing it, and I was just kind of doing reviews. But then now that person left, so I have to actually, like, next 3 months, I have to work on it.
Yeah, it sounds like more statistics and physics. If you're doing time.
It's like a classification of time series, really.
Interesting. I had a question. Oh, hey, Suji.
Hey.
I had a question. Funny question. I'm using UMAP so I've got a word to vec model doing dimensionality reduction, of course, to 2 dimensions using UMAP. And the dimensions are 300. And then I'm using the model, to get the 2D vector representation for content I didn't put in the model, right? Which is fine, right? But the funny thing is I'm like, I was averaging vectors, 300D, so you end up with a 300 dimension vector, and you put that into UMAP, you get 2 dimensions out. But I also tried concatenating, and I put in a 600 dimension vector into UMAP, and it actually works. I'm a little confused by, if you train a model on 300 dimension in UMAP, right, to reduce to 200, how it can actually take arbitrary dimensions, you think?
Oh, you're using the same model to translate to 600 to 2.
Yeah, and
that's interesting.
I want 300 to 2. Is that weird? They use manifold stuff. I don't know what that means exactly, but maybe that's related. But I was surprised. I thought maybe there was insight from that.
No, I actually don't have insight. But so when you construct the UMAP object, right, before you fit it, does it ask about the input number of dimensions?
No.
Only the output, right? So maybe
so the input to get the transformation, or whatever that method is that gets you for a 2D vector, there isn't a parameter asking for dimension, I don't think.
Yeah, actually, well, if you do fit, it should pick up the number of dimensions from there. One other thing, just to check, the number of outputs is it double the number of inputs, number of rows? So I'm thinking maybe it splits the 600 into 300 and does it twice.
No, not that I could tell.
Okay.
That would make sense. I mean, you're right. Maybe it's auto handling it. I'll have to look, but that's not what happened.
Okay. Okay. Yeah.
2D out.
Could it be taking like the first 300 if you fit it 600 dimension?
Yeah, it could be doing something behind the scene, and that's bad coding. If that what they need to do is make it explicit error and then have some sort of override parameter that says truncation is fine, right? Because otherwise that's like something funny happening behind the scenes. But it could be, right? You could be right about that, Yuri. Okay, so there's not some fundamental way it works that it can handle arbitrary dimensions as far as we know. Something funny's going on. But that was just a small aside, not that important. By the way, I looked at that Grade.io, and yeah, it's pretty cool. It's really very, very focused. Whereas Streamlit is more broad in the way it can be used. It's very much focused on machine learning models. So, for example, I can't use it with Jensen because it doesn't integrate with Jensen as far as I could tell. So it's very much probably about supervised machine learning models. So unfortunately, I can't use it for my Word2Vec stuff. But it looks like a great way to test a model, right? Like if you have a model and you don't want to build a GUI, you just use that thing, and if you fit into their use cases, you've got yourself a front end to play with your model. So that's pretty good to have available. So I wanted to give a little demo and ask a question about combining vectors, if that's okay. Is there any announcements that need to be made before that, or should I just do it?
Just do it. Yeah.
Okay.
Yeah, and Sujit, I'm on the phone in the car, so I'll be mostly silent today.
Okay. All right. Okay.
Yeah, we will have to do a little. Okay, so CG, do you see the?
I see a scatter plot.
Yeah, so there's a scatter plot. It's all blue. There's clustering of stuff. This is the Word2Vec. This is the UMAP transformation and the visualization using Bokeh, B-O-K-E-H.
Okay, right, yeah.
Yeah, and so these are remember I've talked about this a couple times, but synthetic sequences for like about 300 editorial articles. It's just titles with the keywords extracted and the topics and products. So what you're looking at here is that distribution, right? And I only have the central tax topics showing at the moment, but do you see that cluster? What is that cluster of dots or semantics? This is all semantics. What is that? What would you call that cluster, CG?
Systems, federal health. There is some health stuff here. EHR systems, okay. Labor union with central tax.
But it's all health, right?
Yeah,
health.
It's mostly health, yeah.
Yeah. I mean, there's dental facilities, healthcare reform. Oops. Just hovering over and it's popping up. And if I hover into different places, it's showing these are all central tax topics from our, 5,000 topic IT taxonomy. And then if I go over here, what do you see?
Architecture design.
Oh, do you see database design?
Yeah.
So that's sort of like a database cluster, right?
Right.
And here's one with AI and machine learning. So first of all, it's really nice to do this because you could check your Word2Vec model, see if it makes sense. And it does for the most part. It makes it pretty good. There's stuff that's clustered pretty well. I can add in products. So product semantics. So that we have a taxonomy about 5,000 products, and those are now in orange. Okay. And they'll show up in here now too. So you'll start seeing, like there, you see towards the top, there's Umbra Health, and it says product tax after it.
Right. Okay.
Those are the IDs. But so immediately it's kind of interesting because we could see sort of where we're missing product coverage in our editorial and where we have strong product coverage and maybe missing a little bit of topical coverage.
So there's like blue area here in the left, middle left, right? Which is mostly not orange.
Yeah.
So those could be like the areas where you could focus on maybe. Yeah, absolutely.
Yeah. So, and this is how you focus on them. You go like this. And you go, you just
Oh,
select.
nice. Yeah, okay.
Check it out. See?
Right. Yeah.
Here's two products. See the orange ones?
Yeah.
But I don't even know what area this is in, but Canada. Okay. Mexico. So I don't know what this cluster is.
Okay, international. Okay, maybe.
This is like non-IT topics. See?
Right. Yeah.
Business area. So of course we don't have products on them, right?
Right, exactly. Yeah.
That actually makes sense. So let's back up. But anyway, that's kind of cool to be able to do that. And I think the business will find that useful in general, maybe. So what I want to do, of course, is add activity to these. So, we have a network of search of sites where all this editorial lives and people opt in. So we actually have known users and anonymous users. So it's basically activity logs from the websites on these pages that I've represented. And I mean, these aren't pages, but of the pages that have the semantics represented here. And I'd like to, of course, be able to size the dots somehow by the amount of activity or what we call accounts that are available, because that's the market opportunity, companies to sell to in that technology. And then what I want to do is do something like this. So you see where it says enter text.
Okay. So you would find the points close to this text.
Yes. Now this is a separate. This will be integrated with the demo I showed before, which has 3 entry points. One, you could put in a URL and get the documents around that and topics around that URL. There's no visualization. You could put in text. Maybe you could load a document. But the point is, whatever you put in there, it turns into text. The text extracts the keywords. And then the keywords is what you query against the Word2Vec to bring back the rest of the things that are in the Word2Vec model, which include the documents. But the idea is we might have a customer and we might say they're trying to run a specific campaign. But this is like Marketo, it's a marketing automation software, right? So maybe we're trying to help align their main business with the semantics, called semantic alignment, right? Which will hopefully align them to the most accounts and stuff that they could exploit, go after. But I'm going to create this. And so what I'm doing here is it's extracting the keywords and it's getting, I can't see it. Oh, I got to do this. Turn off the products. I have some work to do on the vision, but do you see where it put it?
Right, exactly, yeah.
So this is the thing, it's taking the keywords. There's like 3 keywords that are extracted. And then it's what it's doing is it's getting the 300 dimension vector out of the Jensen Word2Vec model for all those 3 keywords, and it's averaging them.
Correct, yeah.
And then it's adding that as a point here. And so you could see the type of, topics that are covered.
Right, yeah.
Marketing automation, and it's right there.
Very nice, yeah.
And lead scoring. So it's doing a pretty good job.
So the document vectors, you created them as like bags of entities or bags of keywords?
So what this is that synthetic sequence thing. So each document, I just get its title and its central text topics and product text topics, okay? So the document itself, so I turn that into a synthetic sequence, which is the doc, it's the title with underscores, and then underscore doc and the ID for the document. So that's one token, right? It's a stupid token, right? This is a big, long token. But then part of the next word token in the sequence is central text. It's the topics that you're seeing here.
Right, yeah.
So there may be 1, 2, 3, or 5 of them, and then the product topics, and then the keywords I extracted from the title.
I see, okay.
Yeah, and And so you're feeding those synthetic sequences. So basically what you're doing is you're finding out which topics tend to show up with which documents, which topics show up with which topics show up with which products. And you're just getting a similarity space between those types, those 4 types of tokens.
Okay.
Doc token, essential tax topic token, a product tax topic token, for the topics, and then a keyword token. So you're just getting a similarity space for those. Is that, you with me?
Okay. Right. Okay.
Yeah. Okay.
So you put all of them into the same sequence, or
yes,
they're separate? Okay.
Same. So I'm calling it a synthetic sequence. It's made up of synthetic tokens. And, I just make the window big, so it takes it all. But one of the key things to this is that because I'm using keywords in this space, right, then I can enter into the space without having to go to my taxonomy and find a topic to enter into it with, right? Or a document. I can actually just take any arbitrary text, extract the keywords, and then I use those as tokens. Those are how I query the Word2Vec space with the keywords. And then I get everything. I get all the similar keyword topics, similar products, similar documents. You see, so it's sort of like a universal, I call it like it's sort of a universal similarity engine.
Yeah, you're basically learning joint representation of all these.
It's a knowledge graph. It's kind of like a knowledge graph trick, right? Because knowledge graph, I think the fundamental definition of the knowledge graph, not from an RDF point of view, from a graph point of view, is you have different types of entities in your graph, right? So I'm not using any graph technology here, but
using vectors.
Similarity between, it's almost like creating an embedding space with a knowledge graph.
Right. Yeah.
That you could then get similar entities that are associated with each other that are different, right? And I think that's what you were saying, kind of, right? Suji?
Yuri? Yeah. Oh, okay. Yeah. Yeah. Exactly. So yeah. So it's a joint embedding representation of different entity types and
of heterogeneous entity similarity space.
Yeah, which allows you now to overlap, right? So the exact same thing you did with the central tax and the product tax, when they overlap on each other. It's very, it's the idea is similar to Clip, right? I mean, you have captions and images in the same space.
Yeah,
so
it's multimodal, but it's not really multimodal. It's just multi-entities.
Right.
Yeah, I mean, everything comes down to similarity space. But the other thing that's nice about it, it's only done on titles, right? So I can, I haven't even done any experimentation to refine this, right? It just, but I could, because it only takes 20 minutes to run locally without a GPU or anything. Because I'm just processing 300,000 titles. That's nothing. Anyway, you with me so far?
Yeah. So the circle here on the red circle, it's larger. Is it like a fixed width circle, or are you using standard deviation or something?
No, it's just bullshit. I just wanted to make it so you could see it.
Oh, okay, got it. Right,
I just gave it a size of 30 instead of a size.
Right. Yeah, totally makes sense. I mean, I was wondering if you did something more fancy with it, like standard deviation.
No. So, but what I did was very simple. Is I took the vectors for the keywords and I averaged them. Okay. And then I take that average 300 dimension vector and put it into the UMAP model to get my 2D mapping. And then I plot it here, right? I actually just have to add it to the pandas data frame that's driving this. But this is why I'm bringing it up to some degree, because I have problems here. So I'm going to now do a keyword query and bring back just documents, okay? Document synthetic sequences from the Word2Vec model. It's a little retarded because I have to do, because I did this very quickly, it's actually just a regex search on the titles, on the tokens in the data frame, but it'll get me, and I take like the first 100 documents, but so it's not the way I would do it really. But so now it's doing the same thing. It's getting the keywords, it's averaging those vectors from the Word2Vec model, and then it's just giving me back documents. Now, you see how a new centroid showed up to the left here?
Yes.
Okay. So it shouldn't be that far away, because look at the title that I'm searching on, the regex.
Oh, I see. Okay.
You see, it's marketing automation, it's marketing, but it's the same thing. Why are they so far apart? I'm using averaging, right? Let me just show you this. If I turn off the central text, you can see the dots. So these are my documents. So do you see what the document
Right.
token looks like?
Mhm.
Yeah. Okay. So you could see these, but that's actually this top one. This is actually the centroid for the marketing one. So this centroid down to the left,
Is the one, the other one. Yeah.
you see when I hover over it, it shows the regex.
Mhm.
That's just how I named it. I just used the regex. But why is that thing? So there's only one, there's 3 documents in here that cover Marketo for some reason, right? The reason probably, so you see those, the reason probably is because they're probably in a security space, because you see how it's breach.
Okay.
They're all breaches. So this is like, there's 3 documents. This is one of the problems with Word to Vec, right? It's not poly hierarchy.
Right.
You can't have something in 2 places. So somehow the algorithm's deciding, well, these are about Marketo and they're about security breaches. So it's sticking these 3 documents in the security breach part of the similarity space, right?
Mhm.
However, look at all these documents. So I'm showing each one of these dots are documents. There's many more of them over here, right? Where the original Marketo, where the correct Marketo centroid is, right?
Right.
Market automation. If you go up here, there's another outlier up here. And I don't know why that one's so far off, but so what I'm saying is my averaging's fucking up, right? With my vectors. Why am it's taking all these documents. So you see them all, maybe there's 30 documents, let's say, right? All these dots. Why would it averaging the vectors end up with the I'm calling it a centroid, but with a, a position way over here in security instead of where all the marketing automation stuff is.
In your second case, though, you're actually averaging over, different keywords, maybe, right? So it might be, so for the first one, you know what keywords you've used, right? So you've just figured out, you have pulled out keywords from this text, the enter text area, right? Whereas with the second one, you have 3 documents for which each of them has its own keywords. Might be worth looking at what the keywords are and how, if they are different ones. I think you mentioned security, so maybe security is one of them, but maybe there are too many of them, so the full mix, right? So the average is getting shifted because of maybe there's a lot of security related keywords, maybe.
So you're saying maybe these documents that I have showing up right now here for you to see, that those documents or those synthetic tokens, maybe they had a ton of keywords with them.
Yeah, I'm saying maybe it might be worth looking at them, basically, right? So just to figure out, right?
So
and then you could say that, if you have multiple same keywords, don't weight them by number, just weight them by existence, right? So you basically weight them once, right? So if you have 5, so let's say your keyword is security, right? Or cybersecurity, and you have 5 of them, you don't give them 5, weight them 5 times, you weight them once in your, in the second case.
So I'm a little confused. Are you talking about at the model build time, or are you talking about at this?
During query time.
So yeah, but you could see that Marketo, Pardot, marketing automation, there's no redundancy in there. So it's going to literally pull out. I don't have it visible here, but it's.
But didn't you take out 3? Aren't you doing like a search on it? So when you say,
Nope. Nope.
Oh, this is one document then. Okay, got it. Okay.
Oh, I'm sorry. I'm so sorry. You're right. I confused myself. That's a regex search on titles.
Okay. So
Right.
you get multiple documents.
Yes, and then what I'm doing is I'm getting the the vectors for each one of those documents in the
Right.
model. Right.
Oh,
So
I see. You're not actually going down to the keywords in there. Okay.
no, literally. I mean, that's what makes this all so simple. Is literally I'm finding this document is one of the documents I found. You can see it's because Marketo is in the name.
Mhm.
And literally, I'm just getting its vector space. So you could see that if you average the vector spaces, it's so many more of the documents are here in the right place, right? In the market automation area. Why do these 3 plus that one above why is that throwing off? So what my part of my question was, should I be using something other than averaging? Is the problem that I'm averaging? So there's a couple outliers. Here's another, there's a couple outliers where the model says, okay, these are marketing automation, but they're more about security, or they're more about, in this case, customer success. So I'm just thinking maybe there's another way I should be combining the vectors that will help take care of this problem.
Can I ask you, so this is the result of your synthetic string, right?
Of what?
This is the embedding for your synthetic string, which is like document title plus keywords plus something else.
Well, the space, the vector space was created. The model, the Word2Vec model was built on those synthetic sequences. Yes.
Okay.
Well, and what we're doing here, we're querying. We're finding, we're taking a couple tokens that we know are in the Word2Vec model, and we're getting the vector for each one and then averaging them.
Okay. So when you create those vectors, so you only take keywords and averaging them, right? You're not taking. So this is what I didn't kind of missed before. So when you have synthetic string, which is document title, I guess some other information, keywords, or there are no keywords in synthetic string, is there?
Yeah, no, the synthetic sequence has a document, which is just the title with the doc ID. It's one token. Set any central text topics it's been classified to. That's a manual thing, very accurate. But it's done in it's metadata. I'm taking metadata in from the doc, which is essentially the topic and the products, and then a couple whatever keywords were extracted from the title. Not like.
So here's my question. How do you create a vector? Do you take those parts of that string, or do you that's like basically you have a vector automatically for that string itself, for that sequence?
Are you saying at model generation at creation of the model time? Training?
Yeah. Like, I don't know.
Yeah. Have you ever used?
No.
Have you used Word2Vec before?
Yeah.
So what do you feed into it?
I think your words, right?
Yeah, sentences, sequences. It has to be
sentences.
individual words. I mean, it learns from the like a sentence. Okay.
Okay.
But you don't actually feed it the text. You actually tokenize it first, and so you have a list of tokens, right? That's a sequence of natural, of tokens. And so this, I'm just
okay. So normally those are sentences, and in your case, those are synthetic sentences.
Yes, that's a better. It's
okay.
Yeah.
Yes, that's exactly right. There's synthetic sentences. I should have said that again. That would have helped. Got a little too dramatic in my language. Right. So then I have. So it just gives me a similarity space that shows similarity between these different tokens. I mean, these different entity types. A central text topic, keywords, central text topic, product text topic, but also documents are in there too. It's not a semantic, but so I guess the real question is there a reason to do something other than averaging maybe that might take care of this particular oddly placed, generated vector?
My question would be different. My question would be, why use Word2Vec? Why not use Bird?
Oh, because Word2Vec's easy. It's what I know, and it was a concept I put together, and we're using it. And yeah, so that it wasn't. Yeah, I do think that would be interesting. I bet it wouldn't do as well because you don't have the volume. You don't have the volume. This is like, because this is sort of still kind of in the old school similarity world. It's kind of like the bridge, right? Word2Vec between co-occurrence stuff and all that, that it doesn't need nearly as much data. I mean, it does a great job on these 100,000 titles. That's not much data at all. So, but I'd love to see and learn more in that area.
Okay.
Yeah. Okay, well, that's what I wanted to show. I mean, maybe I'll try to concat them, but then, it's a funny dimension, and I don't know why UMap's doing that or something, but.
Yeah, looks like it's, well, the overlay should have worked, right? I mean, it's kind of sucks. Just the document ID.
What's that?
The document title overlay should have also worked, right? I guess maybe if you take keywords out of, so one other approach could be that instead of treating document titles as their own thing, maybe treat them as bags of keywords, right? Just the title, and average that as the title space, right? Instead of treating it as its own token.
You mean in the build, in the training the model?
Yeah.
Yeah, no, I get your point. In fact, not having, basically the sentences could have the keywords, the top central text topics, the product text topics, but no,
yes.
And experiment with how that affects the space. That's
right.
a good point.
Or another simple way to do it, even without changing your word2vec, is basically, change your query, right? So when your query comes in, you extract out all the keywords, and then you treat it as an average of keywords, right? The document point.
Yeah.
Right?
So
that.
Yeah. I think that, actually, I think this problem might be solved because I use, when I in my other proof of concept, I use the keywords to retrieve documents, okay, right, that I extract. And those documents, when they come out, they're going to be similar. Like these three outliers probably won't even show up. You know what I mean? If I have, so then it'll probably inadvertently work. You know what I mean? In that use case, because I'm using the word2vec model to get documents that are in a similarity space, then anyway, I was just trying to understand how if there's different ways to combine vectors that might be helpful. I think your point makes a lot of sense as well. Just to show you, just in case you didn't believe me here, I'll do the problem with, let me do this real quick, and then we'll get off this topic. So you can do keywords, but the problem with the keywords, there's a shitload of them, right? Because they're not a control. So see how the keywords make everything so dense, you can almost not see anything. So like all of the central text topics practically are hidden now, aren't they?
Right, yeah.
Yeah. So what's interesting though is you can immediately, it's like a metric, but not a computer metric, a human review metric. You can see the clusters for the central text, the product text, and the keywords are all very similar. So now you see how there's keywords in the healthcare cluster.
Yeah.
So anyway, part of the big picture is none of this would work without having done all this manual classification over the years. It's really the central text and the product text that make this work super easy with no experimentation and quite accurately. And then because I have that framework, all of a sudden I can have keywords, which are now a new entry point into our semantics, which we didn't have before.
Right.
Yeah, so this is part of the story, is the story of taxonomy and manual classification, actually. Right.
And your keywords could now be candidates for one of the two taxonomies, right?
Absolutely. You're right. And you've dealt with situations kind of like this, right?
Yeah.
And so just like we were exploring missing topics too, what we could do with keywords is you could go into a keyword space here somewhere. Let me do it. Let me just see if I can do it. And you can, I don't know what space is here. Let's see. Let's go to this cluster, whatever the heck it is. Data center stuff, not very nice. Let's just go in here, whatever it is. What I'm hoping to see is that So like there's a lot of keywords. What I want to do is find a space where there's no central tax topics, right? But there's a lot of keywords, right? And that might be a place, which is, there isn't much example of here because it's kind of like these keywords, because it might be a place if there's a lot of keywords but no topic, right? That's maybe a hole in your central, your taxonomy.
Right.
Go back to school.
Yep, absolutely.
Yeah. So anyway, it has a lot of interesting applications. All right. Any questions or anything else?
I actually missed, how did you zoom in?
Oh, are you looking now, or do you want me to describe it?
Yeah. No, I'm looking. I got where I was going.
Okay, well, let me refresh this. The keywords there's just too many of them. Okay, you zoom in by going to this little box zoom, and then you just go like this, and you do a box. There you go. Okay, we're zoomed in here. Health claims. So that's how simple that is. And then you just refresh it. And there's products. And then you could zoom in. And that's one of the things. So what I was hoping too is one of the problems we have business-wise that's difficult is we have a new customer that wants to go after a particular campaign for, they're trying to sell their software. And so they want to find the right market to do it in, and so what we have to do is find the right central tax topics, because that's how we aggregate all of our who to sell to information, all of our activity information. And so they have a hard time finding the right semantics or central tax topics to use to segment, right, to create a market segment. And so if they put in, so do, like, say they're sitting down with Marketo and they're trying to find out what central tax topics to use and product tax to segment the market for Marketo. That's an automated marketing automation platform. You just press create here. And I'm going to remove the product so you can see it. Do you see that red circle, Yuri?
Yeah.
So by putting in text, or it could be a URL and you scrape the text and run it, all of a sudden I see, oh, this is where Marketo lives in the semantic space. You see other topics? And so what I was hoping is we could do this. We could go this select box instead of the zoom box and just go like this, which it doesn't do anything. It just highlights it. But you can imagine how that becomes my collection of semantics of central tax topics. And now my job's just about done. I pretty much now have like 30 topics that cover this market, can use them to segment the market. You kind of get that? Oops.
Yeah. So did you build this yourself in Bokeh, or was it like a ready component?
It was a ready component. I didn't write any JavaScript or anything like that. I had to figure out how to. You want to see the code for it, or can you?
Yeah, that'll be cool.
Okay.
Yeah, I haven't used Bokeh, but this is like, this is really interesting.
Yep. It was kind of random how I got the Bokeh. I couldn't get Seaborn or another library to do the zoom and the hover over. Those are like the key things. So I was like, what? And I found Bokeh and I was like, yes. So I've just gone with it. Okay, this is it. Well, here's run semviz. So this run semviz thing here. Can you see it okay?
Yeah.
It's big enough. All right. That's really just taking the data frame of the data points and it's filtering it by whatever I choose in those check boxes. Okay. And then it's setting the data frame semantics to display as a,
like Spark. You can just click display and it just changes the data frame to, okay, got it. Nice.
So I'm just filtering so that that data frame doesn't have documents in it. Let's say if we only checked central tax,
Mhm.
like, so it's just filtering it from this.
Right. Okay.
Yeah, I'm sorry. So we're just filtering it so you just have the right data points in it. And I call that the data frame viz, because that's what we're going to visualize out of the entire data frame. And then it calls this render graph. So this is what you're interested in, Yuri. Take a look at it. Let me know what you want to, there's questions about it.
What line are you highlighting?
What's that?
Are you highlighting the line?
No.
Or?
So it's this render graph function.
Okay, got it. Got it.
So what's the first thing it does? Go ahead and tell me.
It creates a figure.
I guess it's a matplot, like a just picture.
Yeah, it's a creative figure, they call it, which is a glyph in their words. Here's its title. Let's see. Here it is. See semantic space? It says semantic space right there above the graph.
Mhm.
Then the width, the height, where the toolbar is. So that, you know what the toolbar is. That's the on the left. And there's some quirky things, which you can actually say what tools you want in the toolbar right here using strings, but there were certain things I couldn't do. So I ended up instead, you see down here where I define the tools.
Oh, I see. Okay. You add the
You can
tools here.
Yeah, you can define them, you can customize them. What I did was zoom. So there's this,
Mhm.
see on the left side, there's zoom. It's zoomed too slowly. So I made it, I changed the proportion of zoom. So that's what this is, zoom factor 0.4. So anyway, this is your tools in your toolbar. But anyway, so you have your figure, you define your source. So that's the data frame that we just filtered for, the df viz. See, that's the argument for this function. You get your source, which is a data frame. You tell, you know, you have to put it in the OK format or class or whatever. And then what you do is you add this is a glyph, you add a scatter plot to your figure, right? Because you can add multiple figures. You know, you can add multiple plots to your figure and things to your figure. But so you see what comp1 and comp2 are. Those are actually columns in the data frame. That's the source.
Okay.
So comp1 is UMAP dimension 1. Comp2
dimension 2. Okay.
dimension 2 that's in the data frame. Okay, so you're just using a data frame. You're plotting off a data frame. And you're telling it this is the source, right? Which is the data frame. You don't have to use data frames. And then I do this color and marker. I define the colors and the marker types.
Yeah.
So you can see them. And that's it. Yuri, that's it. That's the whole thing.
Very cool.
Not too bad, huh? Once I figured out how to do it.
Right. That's the big part, I think.
That's the hidden part.
Yeah.
But
this is very cool.
Yeah. Yuri, does that give you a sense for a little bit of sense?
Yeah.
Okay.
Yeah, I didn't realize it was a cool way of doing it. I always tried using like ready compose, like basically there are pre-made graphs for displaying you know, UMAP results or any sort of like, you know, embedding. But yeah, I didn't realize you can like quickly build it from scratch. Just do like
yeah. No, I saw that UMAP
points,
has some visualizations. I don't know if they would. It's interesting. You're right. It would be interesting to try one just to see what its affordances are. You know, because it's built for that 2D display. Yeah, it's a good point. The other thing, of course, which is nice, which I didn't even mention, is you see what I'm using here, Streamlit. So it actually has a method. So here's the method, right here, st.bokeh chart.
Yeah, that's actually what attracted me to the first place, the Streamlit part. You know, that you can now, you know, show these cool visualizations on Streamlit. using Bokeh. Bokeh has a lot of its own things it adds on, right?
So let me give you a word of warning. I got totally fucked for a while because it took me a while. I was getting a little desperate, but it turns out that there are compatibility problems.
Okay.
And basically, once I went back to version 2.3 of Bokeh, I don't know what they're at now, but I actually had to roll back my version of Bokeh to get it
I
to.
see. Okay.
Was not exactly explicitly stated anywhere, but there was some help note that sort of seemed to mean that. And so I tried it and it worked. So, when you throw tools on top of tools, especially when they deal with the front end, right?
Exactly. Yeah.
But it is Streamlit, so far it kicks ass.
Yep.
So anyway. All right. Anything else on that? I'll stop sharing if there's no more questions or ideas. Okay. I'm gonna stop sharing. Am I sharing still, guys?
You're still sharing, yes.
Yep.
Oh, there it is, right in front of my face. Usually where things are I can't find for the most part. Okay.
Yeah. No, you're not. Okay.
Good. All right. Well, thanks for listening to all that, guys.
Sure. Yeah. Good. I learned something, so that's good.
Cool. Anyone want to share or ask or anything?
Yeah, I've done. So I don't know if I talked about this before, but projector.tensorflow.org, right? They offer you this similar kind of functionality. I mean, if you just want to visualize your data sets in UMAP, or you can actually you send in your entire data set, and they are able to do UMAP, PCA, and TSNE on it. So you can see them side by side and kind of decide what you want to do.
What's it called?
Projector.tensorflow.org. It's basically a website.
Yeah, it's in data set, and it does UMAP and TSNE and whatever else.
And PCA. PCA is linear, so it's not the best, but that's kind of a baseline if you want to look at it.
Yeah.
Only downside is, and there is in that area where where you can load your own data sets. It's in a specific format. One of them is just vectors, and one of them is any metadata you want to associate with the vectors. And it's limited to 5,000, or even if you are successful at entering, sending in more, it'll only use 5,000 for any approximate nearest neighbor searches. So you can, after you have your thing built up, you can click on it and it'll show you nearest neighbors and stuff like that. Right?
Yeah. It's pretty cool.
Yeah, it's very similar, but it's mainly for developers, not really for showing to people, right? So
what have you used it for before that it's helped you make decision or get insight?
This was actually for a toy project that I did. I wanted to see, basically, it was about a citation graph, and I wanted to see if I could detect clusters. So these toy projects had, these papers, they had author provided tags in the sense that, what is this about, right? Is it theoretical? Is it to do with machine learning? Is it to do with AI, whatnot? So I took those tags as like multi-class labels and tried to color the graph appropriately using that, and tried to see if I could detect any clusters. So what I found was that at the granularity level that the authors provided, those were actually super granular. They actually have larger clusters. I could detect, I think, 2 large ones and a few smaller ones, but they kind of combined the tags, right? And I wasn't actually able to get very much insight out of it, Basically, I found that both the large clusters had like predominantly one of the author tags, very predominant in both cases. One had more of a uniform distribution of the top tags, and one had a more peaky distribution. So I think there were two big peaks there. So, I kind of drew some lame conclusions from that, but not, nothing really, satisfactory.
Yeah, I see. So you looked at the space to see if it was data. It was kind of a data discovery exercise.
Yes, yes.
And you colored the tag. You used the tags. So it really was a citation network. The tags weren't part of the network. They were just used as an
part of the nodes. Yes, yes.
They were used as node attributes.
Node attributes. Yes.
And so you colored. But if you had a bunch of tags, how would you choose a color for the node?
So I took the dominant one, right? So it's like, I think I had I had a rule based on I had a sequence of which ones to take. So in case it had multiple ones, I would choose the first one according to that sorting rule.
Yeah, got it.
Yeah. So that might have been actually one of the biases that caused that peaky distribution.
So what if you did the synthetic sequence with the word devec, that would be interesting in that case.
I actually used the citation graph using Node2Vec. So basically using the structure of the citation graph as the Node2Vec vectors, and then that's what I dimension reduced to UMAP and Disney.
Right. Yeah, I've been watching the Stanford graph videos.
Okay.
And he talked about whole graph classification, I guess.
Yeah.
Subgraph classification, that stuff.
Right.
And they talk about the technique we use, anonymous random walks.
Right.
Didn't make any sense to me. You anonymize, I just could not intuitively understand what was going on there. Is there an easy way to kind of understand what's happening there?
Anonymous random walks.
I mean, another question, less detailed, is have you ever used that subgraph or graph classification stuff?
No.
I mean,
I have to look at it again. I don't remember this.
They give examples of molecules, of course.
Yeah. So the only thing I remember about this was graph classification, and they try to figure out if something is toxic versus non-toxic. But that doesn't have anonymous random walks. I have to look at it again. Sorry, I don't remember this.
Yeah. Okay. Yeah. Thanks for that lead for the visualization.
Yeah.
Try it out. It's kind of cool. Anything you guys have been up to or want to talk about or share?
Well, I now have to look at at least a decade-old Java code to figure out how to add some rules to it. And I'm kind of dreading it because I haven't written Java in years. And the last time I wrote Java, so my last time I wrote Java professionally was Java 8, right? And so 2 years ago, I think I was consulting with another of our groups, and they made me write a Java API, right? So it was like a Spring Boot thing, and during code review, they actually dragged me over the coals for not using the Java 10 features, all the higher order functions. I personally feel that the Java 10 higher order functions are a lot of crap compared to like Scala. And honestly, I can't think, when I think in Java, I cannot think in that paradigm, right? So I expect to be dragged on the coals again this time.
Fun. Sounds like fun. Talking about pain in the ass, did you figure out your reverse proxy problem?
No, I couldn't. I tried that. It didn't work.
And why are you doing Java? What's the context of the project? What kind of work is it?
So it's essentially ambiguous search results. So, when you say, did you mean, right? The ask here is to, so in your did you mean, you say, so in your did you mean, you basically show results for one of them, and you say, did you mean this, right? And then you have links for each of them for their search results, right? So let's say you say cold, right? So you can say, the search results could be for cold, like the common cold. And then you could say, the chronic obstructive lung disease, right? That's also cold. So you would say, did you mean chronic obstructive lung disease, comma, something, and all those are links. So the idea is to now order these by prevalence, right? So when you say cold, I want to show you results for the most common usage of cold, followed by the next common usage, followed by the next common usage, right? In these the links. So that's the basic intent. It's kind of a very edge case. So to do that, what we did was we used the count of results from popular search engines, right? So we use PubMed, and then we took all our ambiguous terms and we hit it against PubMed using two things, right? So we took our ambiguous term and the display concept, right? So if you say cold is the ambiguous term because it can be common cold, like, or it can be chronic obstructive lung disease. So and you say, so I'm doing search results for cold and chronic obstructive lung disease, cold and common cold, right? So I hit PubMed with those and get back search results and the number of search results, which is what I use as a proxy for popularity, right? So this new thing that I finished doing that, right? So I did the hitting of the PubMed and getting the search results, and we have now gone through it and we have said that, okay, this co-occurrence thing is a great way to proxy the popularity or proxy the prevalence attribute. Now we need to apply it so that in this Java code, when it returns the results, it returns it in the order of prevalence rather than random order, which it's doing now. So that's basically the reason for the Java code. And this whole thing that does the random order currently is in Java.
It's funny that you would do this co-occurrence search engine technique. Wouldn't you already get the order of them, like the most prevalent? Why would you ignore that and go random when they did this originally?
Oh, they didn't do this originally. This was an idea that I came up with recently.
Okay. So I got a question. Oh, actually, I have a funny idea. I mean, this is a little out there, but actually, rather than which one, well, maybe not. Maybe in yours, which would you do? The game, who would you do? Well, you could do semantics. You can go, which would you rather? Which is more, people love to do the 1, 2 or 1, 2. And then you do another pair, 1, 2 or 1, 2. That's a way.
Oh, I see. Okay. Like
it's a way to guide it. Yeah, it's sort of like a gamifying, a way of getting a person to specify their language.
Right. Yeah.
Or the entities are interested in. Not that your audience maybe needs that, or I don't know.
Our audience wouldn't play, I don't think. So,
it's not really a game. I mean, you're just showing it in front of them. Did you?
Right. Yeah.
Did you mean common cold or chronic obstructive lung disease? And then when you click chronic obstructive lung disease, you go, well, did you?
I see. Okay. No. The ask here is that we don't just give an empty screen, right? So this would mean that you list them all out in whatever order and let them select, right?
Yeah.
Here the ask is that we show the most prevalent. So we are expected to show smarts here, right? So we say, okay, we know this domain, right? We basically think that this, although this term is ambiguous, we know that most people actually like this. However, you can also look at this, right? We are being more, know-it-alls. Yeah.
Yep, I get it. Nice. Okay. Well, at least you're doing you're doing the shit Java within some reasonable context, though.
Yes.
Context. You're getting something interesting done, so that's cool. Yeah, but the Java, what are we in the 90s?
I know. Yeah.
Actually, our whole company is Java for terms of any web apps they build. It's all.
Yeah. Well, actually, even for the search layer is all Java based. So,
Yep.
Yeah.
Yeah. I do not do that. I learned some Java and .NET a long time ago, but try to avoid that.
Oh, actually, I need to go. I have a catch-up thing.
Okay.
Yeah. So another one-on-one with my business boss.
Okay.
So,
Yuri,
yeah.
did you want to hang on, do anything, or are we all done?
Oh, I just wanted to tell you that I'm using actually a projector also. But yeah, I was trying to generate data to show, but maybe I'll show it next time.
Okay. All right.
But yeah.
Yeah, I have to go. See you
See you,
guys.
All right.
Suji.
Yeah. All right. See you.
Yuri, we all done, or is there something you want to do?
Yeah, no, I'll show projector next time because but I use it for distances only. I know.
Okay, that sounds good.
Yeah. All right. Well, let's do it.
Okay, talk to you in a bit, man. Take it easy.
Okay, thank you.